Hello friends, in today's question, a block of mass m is at rest under the action of force F against a wall as shown in figure. Which of the statement is incorrect? So this is a block, a mass m, force F is being applied on it, and we have to find out which of the statement is the incorrect statement from all these four options. Okay, and it is also given that the block is under rest. So let us draw the free body diagram for the block. So we have applied force F. Because of that, there will be a normal N, and in the downward direction we are going to have a mg, and F is given as frictional force, so this will be a frictional force F, and it's also given that this is A and this is also given as A. So it states that the block is under rest. So for the block to be in rest, all the relative forces as well as torque must be balanced with each other so that the block is in rest. From here we can say for the block to be at rest, all the forces should be balanced, and secondly, balance basically means that the summation of the horizontal as well as the vertical forces, so we can summation of horizontal should be equal to 0 as well as summation of vertical forces should also be equal to 0, and we can also say that torque produced should also be balanced. Or from here we can say summation of the torque should also be equal to 0. If it is x direction and if it is y direction, then that also be equal to 0. So these two conditions it has to satisfy in order to for the block to win in the balanced. So let us talk about the forces first. So in the vertical direction, we have mg in the downward direction and friction F in the upward direction. So under balance condition we can say that our F is equal to mg, and in the horizontal direction the applied force will be equal to the normal. F is equal to normal. Okay. And let us now find out the torque. From the figure we can see that the force is acting along the axis of the center of the mass. You can see the applied force is acting along the center of mass. if it is acting center of the mass, then we can say the torque due to applied force, let us call it a tau F, is equal to 0. Tau F is equal to 0. Similarly, we can say that mg is also acting through the center of the mass. This is COM. mg is also acting along center of mass. Therefore, torque because of mg will be also equal to 0. So you can say tau mg is equal to 0. Okay. So mg is also acting along the center of mass. Therefore, the torque because of this mg will also be equal to 0. Now we have a frictional force F, okay, and that is acting along the, you can say, edge of the side of the block. The frictional force F is acting along the side of the block. So therefore, it will try to rotate or produce torque in the block. Therefore, F will try to introduce torque in the block. So we can say that this is our block and we have a force F which is at a distance A from the center. So it will try to rotate in this direction for the block. Okay. So it means it will be acting in the clockwise direction. Okay. Let us call this torque as tau F. So from here we can say tau F will try to rotate block clockwise. But it is given that the block is in equilibrium. Okay. You can say, but the block is in equilibrium, or we can say rest. Therefore, a counter torque has to be produced. Therefore, a torque acting in counterclockwise is required, and this torque will be produced by the normal N. Okay. You can see here this required torque will be produced by the normal n. Now in the figure we can see that the normal is also acting along the center of mass. So under this condition the normal will not producing any torque. So in order to produce the torque, the normal has to be shifting in the downward direction. You can say therefore normal n should be shifted in downward direction away from the center of mass, away from the axis of center of mass, the axis of center of mass. So let us draw the figure once again. So this is the axis of center of mass, and let us assume that now the normal is acting at this position, which is at a distance of x below the center of mass axis. So this is center of mass axis. So from here we can say that the torque produced by the normal, thus the torque produced by normal, which is given as tau n, will be equal to normal multiplied with the perpendicular distance, which is x. And you can also say that this frictional torque tau f will be equal to your Fr multiplied by F multiplied by A, and F is also already equal to mg, so this will be equal to mg multiplied by A. So now this one is the clockwise torque and tau n is the counterclockwise. So for the block to be in balance, from here we can say for the block to be in rest, tau f should be equal to tau n. Tau f should be equal to tau n. From here we can say tau f is given as mga, and we have tau n is our n multiplied by x, and from here we can find out that another thing, our this normal is equal to the applied force F. We can also say, but n is equal to applied force F, therefore mg multiplied by A will be equal to F multiplied by x, and we can say that our x is equal to mg A divided by F. So this, the normal has to be shifted in the downward direction by this distance so that it is not able to produce the torque. So you can say the normal moves through this distance so that it balances frictional torque. therefore from here it is, we can say we have to find out the incorrect statement. So we have already said that f is equal to mg, we already said it, and so this is true, and f is equal to n, so this is also true, and f will not produce a torque, we also said that this is also true, and n will not produce any torque. So we proved that for n not to produce any torque, it should be moving by a distance of x, whereas the n is along the center of mass. So this is our false statement. So this will be the correct option. So this completes the question. Thank you.